Hello everyone, welcome. This is Miss Fung. Today we're talking about solving rational equations. So this is section 5.3 of our Swift preview of Precalculus. Okay, so today we're looking at rational equations. Hopefully we are familiar at this point with what we do with rational expressions, multiplying them, adding them. But now we're saying that in our equation there is some kind of radical, some kind of square root or other type of root. Okay, so we're going to start by looking at how we solve equations that have just one radical. And we've got roughly four overall steps here. So of course I recommend that you write this example and these steps in your notes. If that means you need to pause, go for it. So our equation is the square root of 24 minus 3x plus 8 is equal to x. And of course, we need to solve for x. So our first step is going to be isolating the radical. Remember, the radical is this piece. We would say that that is our one radical in this equation. So for step one, I'm aiming to get just that on one or the other side of the equation. Doesn't really matter which side. But I'm thinking I probably will just subtract 8 from both sides of my equation, which means, of course, we're eliminating 8 from the left. And we'll have x minus 8 is equal to just that radical, 24 minus 3x. Okay, so it's isolated. It's by itself on the left-hand side. So check, we're done. Move on to step 2. Now we need to square both sides of our equation. I'm going to write this as a separate step. So I'm squaring the entire side there, and I'm squaring the entire side there. Let's fill in those blanks. The left-hand side is square root of 24 minus 3x. And that's equal to x minus 8. Okay. So there's an important note here to FOIL binomials. So I'm just going to write a little reminder to ourselves here that squaring x minus 8 on the right-hand side here, that is not the same thing as x squared minus 8 squared. It is not. What we have to do instead is remember that we have this binomial times itself when we're squaring the binomial. So that's what we mean by making sure to FOIL, if that's how you think about this sort of multiplication. So what we are going to get there, let's see, x minus 8 times x minus 8 will be an x squared minus 16x plus 64. So that's on the right. What happens though on the left? Well, I like to think of this as inverse operations. That is, operations that undo or cancel each other out. Kind of like back up at here where we had been adding 8, so we subtracted 8. Those are inverse operations. Similar, we're taking the square root, but then we're also squaring. So our square root and our squared, those essentially just cancel each other out. So what we're left with is the piece underneath the radical, what's called the radicand, and that's that expression 24 minus 3x. Okay, so we've done step 2. Moving on to step 3, solve the resulting equation. Now, depending on each problem, this might look different. We have a quadratic equation. I'm not going to say that you'll always have a quadratic when we do problems like this, but when we do have a quadratic, we need to either factor or use our quadratic formula. So of course, either of those mean the equation needs to be equal to 0. So I'm going to add 3x to both sides to cancel it out, of course, on the left. And I'm just going to do this simultaneously, I'm going to subtract 24 from both sides. So of course, that's going to leave us with 0 on the left. Then we'll have x squared minus 13x plus 40 on the right. Okay, so whatever you feel most comfortable with or you find to be perhaps the quickest way to solve this, factoring or quadratic formula, that's your choice, really. So I'm kind of thinking I will factor this because I can see right off the bat a pretty straightforward way to do so. So I'm going to rewrite this as x minus 8 times x minus 5. Okay. Of course, once we have it in factored form, we're still solving, so I need to set each of my factors equal to 0. Whether you show all of that work very carefully, that's of course up to you. But I will probably just jump to saying that x is equal to 8 and 5. So we're not done. It looks like, okay, we've got what x is equal to, but this is not it. Okay, excuse the interruption. I had to make sure my cat is not getting into too much trouble over there. Okay, so we do need to check our apparent solutions. Whenever we take this second step of squaring both sides, we can run into a situation where we have what's called extraneous solutions. Extraneous solutions are answers that we get as like a result of solving, but then when we plug them back into the original equation, they actually don't work. And that is a result of squaring both sides. So I'm actually going to go to our next page to give myself a little bit more room to test those two answers. So remember, our equation was the square root of 24 minus 3x plus 8 is equal to x. And the apparent solutions we found were x is equal to 8 and 5. So let's test both of these. Let's see, maybe we'll do 8 first. So that means I'm going to plug in 8 for x into the original equation. 24 minus 3 times 8 plus 8 is equal to 8. Okay. Let's see, 24 minus 3 times 8. Well, that's just the square root of 24 minus 24, square root of 0. So, of course, the square root of 0 is 0. It's not that it doesn't exist, it's simply 0. So 0 plus 8 is equal to 8. Yeah, that's a true statement. I probably could have said, okay, from here, I know that that's going to be true. But that means, yes, 8 is one of our answers. Now we just need to make sure to check 5. Is 5 an answer? So let's see, the square root of 24 minus 3 times 5 plus 8 is equal to 5. So we just have to see, is this true? So let's see, the square root of 24 minus 15 plus 8 is equal to 5. So the square root of 24 minus 15, that's going to be the square root of 9 plus 8 is equal to 5. Square root of 9 is 3. And I think we're seeing this is not going to work out. 11 is not equal to 5. So unlike when we talked about this kind of situation, running into a false statement like this, we talked about last time that meant, oh, there's no solutions. In this case, that just means 5 is not a solution. We do still have a solution, and it's x is equal to 8. We would describe 5 as an extraneous solution. Extraneous. Meaning it's actually not valid. Okay, so x equals 8, that's our final answer. We generally don't need to actually write anything about our extraneous solutions. I just want to call out that that's where that one went. Okay, so that's how we work with equations with one radical. What we end up with 2. So this is kind of going to be the same process, but maybe an extra step or two depending on how many radicals. So I should really call this 2 plus radicals, not just 2 alone. So the idea is we want to start by isolating just one of the radicals, meaning we want just one radical on one side of the equation. So the other side might still have a radical, might have even more than one radical. So let's see, in this case, with our equation, the square root of 5x minus 1 minus the square root of x is equal to 1. I think I will start by adding the square root of x to both sides. What that means, of course, we cancel it on the left, so we have isolated the square root of 5x minus 1 on the left. We have 1 plus the square root of x on the right. Okay, so that's step 1, pretty similar to before. Step 2 is also, we need to now square both sides, and again, remember to FOIL any binomials. So I'm going to square the left-hand side and square the right-hand side. Like we talked about before, when we square a square root, those undo each other. Those are inverse operations. So on the left, we'll just have 5x minus 1, that radicand, the stuff underneath the radical. Now, what about the other side here, though? 1 plus the square root of x squared. Again, I'm just going to remind us that this is not the same as 1 squared plus the square root of x squared. No, no, no. Instead, we need to FOIL this. So I'm actually going to write this maybe off to the side. Let's do it in some other color, like purple. So this is basically 1 plus the square root of x times itself. So it might be helpful for you to really go into where this comes from and FOIL very carefully. So of course, FOILing means multiplying our first terms. That's supposed to be 1 times 1. So we'll have 1 times our outer, or plus our outer terms multiplied, so plus the square root of x. Okay, then our inner, that's another square root of x. There's a couple of like terms there. And then our last. Okay, so our last, that's going to be the square root of x squared. Another case where those operations undo each other. So we could simplify this to 1 plus 2 times the square root of x. That's the square root of x plus the square root of x, plus just plain old x. So that's what I should have on my left-hand side. I'm actually going to scoot this next line down a little bit. So we had that 5x minus 1, and it's equal to 1 plus 2 root x plus x. Alrighty. So our difference next is in step 3. We don't just jump into trying to solve like we did with the quadratic we ended up with before. We actually now need to repeat steps 1 and 2. We repeat steps 1 and 2 until there aren't any more radicals left in our equation. But of course, we do still have a radical. So my next step is to isolate that radical. So I think I will subtract x from both sides, and at the same time I'm going to subtract 1 from both sides. So we're going to cancel those guys out, and let's see, we're left with 4x minus 2 is equal to 2 root x. So right now on the right-hand side, the radical is not technically isolated. It's still being multiplied by 2. I certainly can continue and isolate, that is dividing both sides of the equation by 2. And we would get what? 2x minus 1 is equal to the square root of x. I also, though, could skip that step and jump into squaring both sides. So I could square 4x minus 2 and square the other side. both options will lead to the same answers. So do whatever you feel is most comfortable for you. I'm going to continue with the square root of x being completely isolated. Okay, so I'm going to move on, and now that we've isolated the square root, square both sides. So let's see, 2x minus 1 squared. Hopefully we're catching on that that's not the same thing as 2x squared minus 1 squared. We need to FOIL. And let's see, when we do FOIL, we'll get a 4x squared minus 4x minus or plus 1. Plus 1, yeah. And that is equal to, okay, same thing's happening here, our square root and our squared that's undoing each other is equal to x. So we do end up with another quadratic. So again, we're going to want to solve this using either factoring or the quadratic formula. But of course, it needs to be equal to 0 first. So let's subtract x from both sides and get 4x squared minus 5x plus 1 is equal to 0. Okay. Notice that our following steps are to solve the resulting equation and then again to check the apparent solutions. That's what we have coming up next. I'm going to go give myself a little bit more space here. So let's see, we had 4x squared minus 5x plus 1 is equal to 0. So I'm going to factor this, I think. And you could think about doing that a couple ways. You could think about doing that using grouping, using guess and check, whatever is your preference. You could also not factor. You could plug this into the quadratic formula instead. Yeah, you really have options. Now this does factor as 4x, 4x minus 1 times x minus 1. Okay. Of course, that means each of our factors can be set equal to 0 in order to solve for x. So we'll find that x is equal to 1/4 and x is equal to 1. Okay, so we certainly need to check back into our original equation that these answers are valid or eliminate them as possible answers. So I'm going to rewrite what that original equation was over here. That was the square root of 5x minus 1 minus the square root of x, and it's supposed to be equal to 1. So I'm going to test 1/4 first. Let's plug in 1/4 for x. So the square root of 5 times 1/4, and we've got fractions underneath square roots, okay. All right. Now we're also subtracting the square root of 1/4 and trying to make that equal to 1. So let's see how this simplifies. So 5 times 1/4, I'm going to represent that as 5/4, and I'm also going to change minus 1 into minus 4/4, just so that we have common denominators. Okay, so we're still subtracting the square root of 1/4. All right, so if I look at that first radical, 5/4 minus 4/4, well, that's 1/4. So I'm saying the square root of 1/4 minus the square root of 1/4 is equal to 1. Well, the square root of 1/4 minus the square root of 1/4, that's 0. I don't even need to necessarily identify what the square root of 1/4 is, because I'm just subtracting it from itself. So I get an equation saying 0 is equal to 1. Nope, not true. So that tells us x cannot be 1/4. That is an extraneous solution. So now I need to check, well, is 1 a solution? If not, then I actually would find there are no solutions to this problem. But hopefully 1 is a solution, so I can walk away with something here. Okay, let's plug this in. So we'll start with 5 times 1 minus 1 minus the square root of 1 and see if that is equal to 1. Okay, so 5 times 1 minus 1, that's just going to be the square root of 4 minus the square root of 1. Is that equal to 1? Okay, the square root of 4, that's 2. The square root of 1 is 1. We're saying 2 minus 1 is equal to 1? Yeah, that's a true statement. So yes, x is equal to 1. That is our one and only solution in this type of problem, or in this problem. These types of problems can have no solutions, which means the apparent solutions that we get both do not work when we plug them back in. We can also have multiple solutions. We could find problems where all of the values of x that we find do work when we plug them back in. And we can have situations like this where we have just one solution. Okay. So next up, I've got some practice problems. Get to my next slide. Here we are. So my recommendation is to pause the video and practice solving these equations. On my next slide, I'm going to show the answer. So I'm going to start a countdown here before those answers and like the work leading to those answers is displayed. But I, of course, highly recommend giving yourself the chance to get some practice on your own. So practicing going through those 4 or 5 steps depending on the problems. Okay, so I will start my countdown. And here are the answers. Okay. So of course, please do let your teacher know if you've got any questions. We would be more than happy to go over any of these in detail, go over, of course, the homework problems in detail. Otherwise, I hope you have a great rest of your day. Bye. Thank you.